afternoon. My name's Nelson, and in my group there was Sarah Smith, Emmanuel Akintitan, Glenn Glass, and me. And we were going to be talking about green technologies in oil and gas production activities. So, the reason we're talking about this is because there's a great need for it. Oil prices are rising, and the era of easy oil is over. Oil prices affect a lot of industries, like food industry, the fertilizer, irrigation, and transportation. For instance, if oil prices go up, it costs more to transport food, and so then transportation will go up. It costs more to feed the animals that produce fertilizer, so the fertilizer costs are going to go up, things like that. The one possible solution is getting everyone in a race to adapt to these things by researching and developing eco-friendly manufacturing processes for oil. Next slide. So one thing is biofuels. So primary biofuels, basically biofuels in general, are any plant matter that can be used as fuel. So biogas is one of the fuels that is decomposed when it's a result of the decomposition of plant matter. And it has the capacity to meet only 3% of the energy needs in the US. So the way they make biogas is through anaerobic digesters. And basically they're like containers that they put the organic matter in, whether it's food or compost or whatever it is. And when the decomposition happens, it's funneled and the gas collects. So the good thing about anaerobic digesters is they control the organic matter so it doesn't pollute the groundwater, and it controls the rate of decomposition. Another type of gas is landfill gas, or LFG. It's similar to biogas, but instead of using plant matter like leftover food or whatever, it's garbage, so all kinds of organic matter, not just type of food. And it releases carbon dioxide into the air. That's one of the downsides of it. It also releases the biogas which they use. So biofuels are split in different categories. First generation biofuels are derived directly from food sources, which is what I talked about earlier. And these things are usually cultivated in anaerobic digesters, and they're mainly made from starches and sugars. A really big one is corn, and corn is converted to ethanol through something called dry milling. Good thing about corn is it's really cheap to grow. It's really easy to take care of. But the bad thing about corn is it requires a lot of energy to make, and after all is said and done, after they've produced the energy to make the ethanol, it only has a 20% energy yield. Sugarcane is actually a pretty feasible one because it has a 40% energy yield after all is said and done, but it requires a large amount of land to grow it. So using food for the fuel sources like corn and sugarcane, the downside of that is it increases the cost of food, so that can kind of offset the economy. The second generation biofuels, they're things like wood and feedstock. So like wood shavings when they produce wood and manufacture wood, the leftover wood shavings, these are like the second generation biofuels. So they use a process called gasification, which turns them into syngas. And syngas, or synthetic gas, is composed of carbon monoxide, carbon dioxide, and hydrogen. There's still a lot of land required to grow these things, but the food sources are not directly impacted because it's just leftover wood and stuff. So another way they use to process these wood shavings or feedstock is called pyrolysis, and it's thermochemical conversion to produce this biooil. So a lot of heat, and it kind of gets the oil out of it, and so you get the bio-oil, which can be used as a fuel source. Or torrefaction, which is similar to pyrolysis, but it occurs at lower temperatures. And the good thing about this is it requires a little more energy, but it produces a clean and easily storable bio-oil. And then, of course, biodiesel, everyone knows about that. Biodiesel has good ecological and medical benefits, as well as using leftover oil from like food making and stuff. Third generation biofuels are considered as anything that is produced from algae. So the good thing about algae is it's not a food source, and you don't have to have a large amount of land to make fuel from algae. The fuel that is produced when you process algae is called butanol, and it has very similar energy density to gasoline. The good thing about algae is it's able to, if we start using algae, we could satisfy the energy needs for the whole United States with just using 0.5% of United States landmass, which is super doable. Algae produces 9,000 gallons of fuel per acre. That's really high. The only downside to algae is you use fertilizer to cultivate the algae and help it grow, and fertilizer production, there's a lot of greenhouse gases associated with that. Methane reformation, autothermal reforming. So this is ways of creating methane from these biosources. So autothermal reforming, you oxidize the methane with heat, so you combust it and it releases the energy. But the best way to do this is using oxygen, because otherwise it's really inefficient. So the downside to using that is oxygen is really expensive just for pure oxygen, because they have to refine it from air. Another way is steam reforming. Steam reforming is a little bit better. It's cheaper because, you know, steam, you can just boil water, and that's used to oxidize the methane instead of oxygen. But in this reaction, it's endothermic, so it absorbs heat instead of giving it off. And then we have dry reforming, and it's a very inefficient process, and it's not really feasible, but it's worth mentioning here. They use carbon dioxide to oxidize methane. So methane gas hydrates, basically it's methane gas that's trapped inside these crystals, and these crystals form at either low temperatures or high pressures, either or. And they're commonly found on a lot of coastlines near the ocean floor or the ocean bed. And they have a lot of potential energy. Actually, it's said that they have more potential energy than all of the world oil reserves combined, which is amazing. But the downside to it is, yeah, they're pretty easily accessible, but it's on the ocean floor. So to get to the ocean floor, you have to have a lot of capital and a lot of machinery that has to go to the ocean floor and mine these things. And there's a lot of adverse environmental impacts with that. The only hydrates that they actually find now and mine and are able to be mined are near the ocean surface, so not near the ocean floor. And this is to appease environmentalists. So oil sands are where they get oil from. It's basically kind of like raw oil. So a naturally occurring mixture of sand, clay, water, and bitumen. And this is like in the Middle East. They have all the oil sands over that's how they get their oil. Over 2 trillion barrels of oil are stored in the world's oil sands. And it's not very easily extractable because it's in the sand. And the current methods they use are environmental friendly. And I mean, they're doing it in the Middle East, and they don't really care about the environment like we do here, so they make a ton of it, and it's just not very sustainable. The extraction problems make it difficult to use oil from sands as a valuable fuel source. So eventually it's just going to run out, and it's not very sustainable. So MCW Energy Group has developed the world's first environmentally friendly process for extracting oil from oil sands. That's a really big thing. The process doesn't use any water, and it only creates a small amount of greenhouse gases, and it doesn't require high temperatures like a lot of the other processes I've talked about before. And the process is able to extract up to 99% of the hydrocarbon solvents and recycle 99% of the benign solvents in the oil sands. So this is the way they do it. The first step is they crush the oil sands, and then those crushed oil sands are fed into a fluidized bed extractor. And what that does is it basically continually mixes a solvent, allowing for continuous flow of materials. It keeps it nice and fluid and mixed around. So that liquid is then transported from the extractor column to the evaporator, and then to the distillation column. And the third step is the oil and the bitumen are separated from the solvent through distillation process and delivered to a storage tank. The fourth step, the solvent is recycled for the next batch. And the fifth step is the drying process and sand removal. So that's where they actually take the sand out of the oil. Oil shale extraction. Oil shale is an organic, rich, fine-grained sedimentary rock from which oil can be extracted. So that's more, oil shale is more in the U.S. because so oil sands is like the Middle East. It's a lot of hotter climates, and oil shale is hidden in the rocks. So you have to drill a lot deeper for it. It's a good source of bitumen and carrageen. Usually extraction is done by pyrolysis, which is achieved at high temperatures, so basically burning. The amount of energy needed to reach these temperatures is not very efficient. So using solvent to extract oil from oil shale is more efficient since it can be done at low temperatures. So instead of burning it, they just use a solvent to help extract all the oil out of it. Bioethanol is a possible environmentally friendly solution to this problem. So next slide. Dope-free technology. Pipe dope, a product used to join threaded connections of tubing and casings for pipes. Protects against corrosion and provides lubrication for connection, but also protects against thread gailing. Pipe doping can lead to different problems inside wells, including clogging, wireline failures, and can cause failures during data collection. It can also cause damage to the well itself and surrounding land. Dope-free technology can save many of these problems. It can solve them. So one way of doing it is using a dry coating that's applied to the connections, and then another one is using dopeless connections. Recycling of carbon dioxide, another process of green fuel processing. Carbon dioxide is naturally recycled through plants, so our current carbon dioxide emissions are far greater than what the environment can recycle naturally. That's a bad thing. It means we have extra carbon dioxide laying around. Chemical processes can be used to mimic the natural process of converting carbon dioxide into fuel. New fuel sources can be created while reducing the environmental impact. By capturing carbon dioxide from industrial sources and using a process known as reductive hydrogenative conversion, carbon dioxide can be recycled into methanol and dimethyl ether. These can be used as fuels or to produce synthetic hydrocarbons. And this would be an inexhaustible source of fuel. There's just so much of it, and it recycles. So in conclusion, there are many different green production activities in the oil and gas industry. As I talked about before, biofuels, and then methane gas, which you can make from corn and sugarcane. Then the oil sands, so different ways, more efficient ways of processing those we talked about before. Dope-free technology, so pipe doping, instead of using pipe doping, use things that don't affect the environment. And carbon dioxide recycling, which is the circular process that it's inexhaustible. So these processes can lessen the environmental impact of energy production in the oil and gas industry.